Hello, everyone. Welcome. This is very exciting. Good evening, good afternoon, good morning, wherever you are in the world. I'd like to welcome you all today to the first workshop from the new Center for Research on Foundation Models. We're delighted that you're here. So the Stanford Center for Research on Foundation Models, which we call CRFM, is a newly established interdisciplinary center with a team of more than 100 researchers born out of the Stanford Institute for Human-Centered Artificial Intelligence, or Stanford High. Its goal is to make fundamental advances in the study, development, and deployment of what we're calling foundation models. You'll be hearing a lot more about what this means during today's workshop. Stanford is the first university to launch an initiative to examine these extremely nascent, but yet already profoundly impactful models. This requires deep interdisciplinary collaboration between multiple fields, as well as multi-stakeholder dialogues across academia, industry, civil society, and the policy world. We believe that this is exactly what a university is well suited for. Many of you here today are already friends and colleagues of Stanford High, but we also have some new friends too. So for those of you who are not familiar with Stanford High, I welcome you especially. We founded High in 2019 with the goal of taking a human-centered, multidisciplinary approach to helping further the development of AI. We have a vibrant community of scholars and researchers across the entire Stanford campus and beyond the walls of our university. They're not only computer scientists, but also neuroscientists, physicists, economists, historians, clinicians, legal scholars, political scientists, philosophers, ethicists, artists, writers, and the list just goes on. With such a breadth of expertise, we firmly believe that we're together exploring a new framework to conduct AI research and education. And our newly founded CRFM is truly a unique embodiment of what we are built for. And now, I'd like to introduce today's MC, Percy Liang, an associate professor of computer science department at Stanford University. Percy doesn't need much introduction in the world of machine learning and natural language processing. His research spans many topics, including robustness, interpretability, semantics, and reasoning. He's also a strong proponent of reproducibility through the creation of CodaLab worksheets. He has won numerous awards that I cannot possibly list, but some significant ones include the Presidential Early Career Award for Scientists and Engineers, HGI Computers and Thought Awards, and an NSF Career Award, as well as a Sloan Research Fellowship. So without further ado, I would like to hand over to Percy. Thank you.
All right, thank you, Fei-Fei, for the warm introduction. And I'd like to thank everyone for being here. I'm really excited to be organizing this workshop with my student, Rishi Bomasani. I first want to thank all the High staff, students, faculty, postdocs, researchers who worked tirelessly to make this center and workshop possible. So for those of you who don't know me, I'm a bit of a skeptic. You know, when deep learning was storming the field of natural language processing, which is my main area of research, I was skeptical that it would lead to true language understanding, and I wrote many papers showing its limitations. But sometimes there's just facts on the ground that you can't ignore. And what I see today is the very beginning of a paradigm shift, which we've been calling foundation models. These include things like BERT, GPT-3, DALL-E, and Codex. And I think this paradigm shift is going to have profound implications on how AI technology will develop, who will have access and have a say in how it develops, and there will also be heavy social consequences that result from each technological decision. So I'm going to describe foundation model using two words, emergence and homogenization. So technologically, foundation models aren't anything new. they're based on a decades-old idea called self-supervised learning. So the idea of self-supervised learning is you take a lot of raw data, text or images, and you make up these little exercises. For GPT-3, it's predict the next word of a sentence. Then you train a powerful neural network to solve these little exercises. It's like weight training. By doing these exercises, the network develops the muscle to recognize an immense array of patterns and abstractions based on the data it's given. Now you do this at scale. For GPT-3, it's 175 billion parameters, 570 gigabytes of text. And what emerges is quite surprising. So we've probably always seen how GPT-3 can generate fluent text and code. But the thing that really got me was the emergence of new capabilities. So one thing that GPT-3 can do is in-context learning. So you specify a description of a task that it's never seen before, and it can often do a surprisingly good job of it. Now, this is not how machine learning is supposed to work. Sometimes I can barely get my ML models to generalize to new examples, but here we're talking about generalization to new tasks. So this emergence is what excites me and also freaks me out at the same time. So in engineering, you generally design and you build a system to do something, say to translate sentences. But with a foundation model, it's different. You first build a foundation model, and then you go and discover what it can do. It's less about engineering, more about scientific discovery in a sense. And what this means is that I think we've uncovered a very small fraction of the capability surface of the existing foundation models, let alone the future ones. So the other word that I want to use to describe foundation models is homogenization. This aspect is more sociological, but perhaps even more important. So it used to be the case that every task in AI would be its own subfield. So using NLP as an example, you have a sub-community of people working on building question answering systems with their own set of bespoke methods and data sets. You have a sub-community of people working on machine translation with their own set of bespoke methods and data sets. And same for parsing, sentiment, and coreference resolution. But the story of AI has been one of homogenization. With the rise of machine learning in the late 90s and the 2000s, we have a homogenization of the methodology and the algorithms, the whole idea of collecting data sets and training to minimize some loss function. And then with deep learning, we had a homogenization of model architectures. We have LCM, CNNs, and especially now with transformers. And now with foundation models, we have the homogenization model itself. So where we use a foundation model that's not trained for any particular task, and we're able to productively adapt it to a wide range of downstream tasks. So it's remarkable that now every state of our NLP system I can think of uses some foundation model, and this only happened in the last 2 years. So now we could refer to these models as pre-trained models or self-supervised models or language models for those that are of language. But we feel like none of these terms really highlighted the foundational role that these models play in building AI systems. Now, I should immediately say that when I say foundation, I'm not suggesting it's a good foundation, or even that AI systems should be built on the existing foundation models. In fact, it's well documented that existing foundation models have tons of problems. They lack common sense about the world. For example, GPT-3 thinks that a pencil is heavier than a toaster. They lack internal consistency. It might look like GPT-3 knows that 1,000 plus 4,000 is 5,000, but if you remove the commas from the input, it gets the answer wrong. And these are not one-off examples. They're pervasive. So existing foundation models, despite their impressive capabilities, still display a profound lack of understanding when you inspect them closely. Now, the dangerous part is that they seem like they understand, so we might be lulled into a false sense of security. And they work most of the time, but is most of the time good enough to serve as a foundation for future AI systems? Certainly in other areas of engineering, such as bridge building or airplane manufacturing, this answer would be a definitive no. Perhaps an even bigger worry with foundation models and AI technology more generally is the harms that they may inflict on members of society. And marginalized populations always get hit the hardest. So the behavior of GPT-3 is ultimately shaped by the data it's given, which is dominated by internet text. And as a result, it's not surprising that GPT will generate offensive context and perpetuate stereotypes. James Zhou will talk more about this tomorrow. GPT-3 can also unintentionally generate untruthful text. But Moreover, it can also be intentionally by malicious actors to generate untruthful or simply not falsifiable text. And this could enable larger scale disinformation campaign, which is a really scary thought. So Shelby Grossman and Sarah Krebs will also talk about this tomorrow. So at this very same time, big tech companies are all developing foundation models and deploying them at scale. For example, Google Search has been using BERT as part of their ranking algorithm since late 2019. Facebook has been using models such as Roberta and XLM for hate speech detection since last year, and there's many overseas efforts and startups. So we have these foundation models with a lot of raw potential, but because of their emergent behaviors, they are difficult to understand and control. Now, of course, it's not the actual foundation models that's being exposed directly to a user. They're adapted to the task, and there's various precautions that are taken. But even these measures are far from bulletproof. So in any case, there's huge economic incentives to deploy these models at scale. There's lack of norms and regulation, and it's very likely that the pervasiveness will continue to grow. So it's really urgent that we as a community now act to make sure that these models are developed and deployed in a way that promotes social benefit and minimizes its risks. So, but sadly, it's becoming harder and harder for the community to engage. Stepping back a little bit, a big but often underappreciated factor in driving the deep learning and AI revolution is the incredibly open culture and open ecosystem. It's the norm that researchers release their data sets and code and tutorials so others in academia and industry can learn and build on top of them. And this has led to the astonishing progress in the field. But with foundation models, this openness is being eroded, with data sets and code increasingly not being released. For example, while some models like GPT-2 and T5 are public, the code for training them is not. And with GPT-3, even though a few people could get API access, the models are not available. Openness, I would say, is such a basic requirement for scientific integrity. It's what enables the community to collectively critique, validate, and build off of each other's work. And without it, we're just not doing science. I want to highlight two important efforts in the community that are promoting openness. So first is Luther AI, a grassroots organization that has released the Pile, a large curated data set of English text. And they've also managed to train a GPT-2 style 6 billion parameter model. The second is Hugging Face's big science project, which is really impressively decentralized and open effort across the world that aims to build a very multilingual large language model over the next year. And we have been interacting with both groups and have been quite inspired by them. But openness is necessary, but not sufficient. Training large foundation models still requires engineering expertise and lots of compute, which makes them out of reach for less well-resourced organization. And these are usually the ones that are trying to open things up. So now startups such as AI21 Labs are still able to build the largest models right now. But based on the way that things are trending, it's really unclear whether that will even remain the case. So why is accessibility so important? Can't academia just work on core methodological improvements or smaller models and have industry take care of deploying them? Or can we just take larger models, which are released already, and just analyze them? I want to say this is not enough. So the emergence properties of foundation models means that you'll miss things if you work at smaller scales. If you're working with a 1.3 billion parameter model for GPT-3, it doesn't look like in-context learning is working. It's only when you scale up that you see it. And after all, self-supervised learning has been around for a very long time, but it would never have the far-reaching impact it has today without scale. So second, just having access to a model fundamentally limits the questions you can answer, or even ask. So machine learning is about the process by which data and model architecture work synergistically to produce a model with certain behaviors. To study learning and improve it fundamentally on the status quo, you need to be able to study this process. You need to be able to change the data, you change the architecture and measure what happens. You can't just look at someone else's trained model. And as we've seen, the bias and robustness problems posed by existing foundation models run so deep that we really need the ability to reimagine these models from scratch. But again, this requires resources, and how do we reduce this resource gap is very much an open question. And I hope this is one of the biggest topics that we can discuss at this workshop. So we are facing some serious technical and social challenges regarding foundation models. They're not even right answers here. So we definitely don't want a single or even a few organizations dictating where the technology is headed. So currently, we lack even basic professional norms about what is acceptable. When is a model even safe to release publicly? Should we filter out toxic content before we train? Should we build a foundation model and report what evaluation metrics and about its environmental impact should we report in? Should we even be building foundation models? And to answer all these questions, we really need input from a diverse set of voices. We want representational diversity. Ultimately, these models will impact people, and we want to make sure the stakeholders, especially minority populations that are impacted, are well represented among the folks making decisions about the future of these models. We also want institutional diversity. This is too important of a matter to leave to a few big tech companies or even a few well-intentioned universities. And finally, we want disciplinary diversity. Given the highly socio-technical nature of these models, it can't just be AI researchers or even computer science researchers. We need experts from law, political science, economics, information science, sociologies, and STS to come together and work on these problems together. So the need for this interdisciplinary diversity is what ultimately prompted us to create this center at Hive. And I want to tell you a little bit about the backstory of how we got here. May 28, 2020, the GPT-3 paper came out. And I must say, this was one of the most surprising results I've ever seen. But I was dismayed that the model wasn't released. But this was in the middle of a pandemic with two kids at home. I really couldn't be thinking about doing anything about it at that moment. October 14th, Hive hosted a workshop, which included researchers from Stanford, OpenAI, and a few other institutions about the scientific and societal aspects of GPT-3. At that workshop, at one memorable moment, Jack Clark said that universities should really be building GPT-3 too. Kind of crazy, huh? But that triggered a sort of, moment for me. The next day, the NLP faculty, Chris Manning, Dan Jarofsky, Chris Potts, Tatsu Hashimoto, and I were chatting about this. And I asked, well, what would it take for us to train a GPT-3? I slacked Chris Ray because he always liked crazy ideas. And of course, he said he was in. So then I emailed Fei-Fei and asked, is this something that I would be interested in? And she replied very enthusiastically, encouraged us to think big. So then, even though Replicate GPT-3 had been the initial instigator, we quickly broadened our scope. It was clear that there was a lot of things that the various researchers at Stanford could and should be contributing to the conversation. We just needed to figure out a way to best coordinate our efforts. So we decided on two parallel tracks. The first thrust was to develop tools and expertise for training large models that could support a wide range of research projects, not just at Stanford, but in the entire community. So we formed a small team of students and postdocs. While our first concrete milestone was just to reproduce GPT-2, our overarching objective is about the process, not the final model. We weren't interested in scaling up to the largest model or the fastest model. We wanted to make training accessible by releasing open source tools so that different domain experts, people from law or medicine, could actually train their own models on their data. And we wanted the process to be reliable, which is not actually a given, as we found out. So on this thrust, we've been discussing with Hugging Face and Eleuther AI. You'll hear more from Sid and Laurel about this tomorrow. So the second thrust is building community. And this was based on the observations that there were a lot of people at Stanford already interested in fact, working on these models. And Hive really made it easy to find them. So thanks to Deep Ganguly for coordinating here. Beyond the usual suspects in the NLP group, we had folks improving the parallelism to scale up, trying to achieve theoretical understanding, trying to build video models for vision and robotics, studying the bias of these models, studying the misuse of these models for disinformation, the economic impact, training a legal bird for law applications, etc. And you'll hear from many of them over the next 2 days. So we thought it would be really productive for everyone in Stanford to talk to one another. So together with my student Rishi, we've started this community at Stanford so that people could get to know each other. And here we drew a lot of inspiration from Hugging Face Big Science Project. If they can bring the entire world together, surely we should be able to do something smaller scale at Stanford. So at the end of March, we started having weekly meetings just to get to know each other. The community quickly grew, and now it has over 175 students, postdocs, and faculty, research spanning 10 different departments. Every week we had breakout rooms, spotlight talks, we had an active Slack. And for me and many others, it was really an eye-opening experience to learn from the people from so many disciplines. For example, I had a lot of great discussions with Rob Reach and Katie Creel, which you'll be hearing from tomorrow, on the ethics of foundation models. There was a lot of energy in the community. And over time, we also got more conceptual clarity on how to even think about what's happening with these models. So one day, about a month later, Rishi and I were chatting with Chris Potts, and Chris suggested that we should really try to write down all these ideas that have come out of these discussions. But we had over, at that time, 150 people in the community. So how could we even begin to do this? So we had another crazy idea. Maybe we could just get everyone together and write a report. And that attempted to cover all the aspects of foundation models that we had, well, at least the ones that we had expertise for. This was an experiment. And we figured, well, in the worst case, if the report didn't pan out, people would at least have gotten to know each other better and have learned something out of the process. So we laid out 26 sections ranging from applications like healthcare and law to the technology of the systems or theoretical understanding to societal concerns like the impact on inequity, environmental impact, the risks of misuse. And we just had people sign up to help out with the various sections. It was a very kind of bottom-up kind of effort. Each section had a student and faculty lead, and this structure actually worked surprisingly well. So within each section, we had people from different research groups that came together to learn from each other. We also got sections to talk to one another, which really helped the report become one cohesive unit rather than a bunch of independent sections. For example, healthcare applications had special attention to privacy concerns and as well as ethics. So here, 3 sections had to coordinate on their kind of joint message. So in about 3 to 4 months, we released the report publicly on arXiv. And the end result was a 200-page paper with 100 authors. I had initially set a 1-page limit. So I think at least one section went over the page limit here. So undoubtedly, there's a lot that we weren't able to do justice in the report, and we're still iterating on. So if you have any feedback, please contact us. So this report represents perspectives from Stanford, but as I mentioned before, institutional diversity is important. So the purpose of this workshop, similar to the recent iClear workshop, Enormous Language Models, is to bring the community together to share and discuss issues pertaining to foundation models. So the workshop is over 2 days, has 4 sessions. Session 1 is like a musical overture. It will touch on many of the general themes around the benefits and risks of developing these models. Session 2 will challenge the technical foundations. How can we better understand these models and how do they generalize to other modalities? Session 3 will explore the impact of these models are having on industry and discuss the potential impactful applications. And finally, session 4 will discuss the social implications on these models, in particular, the harms that these models can inflict on people. So I want to end with some food for thought. So the current path of foundation models towards models that we don't really understand, trained on massive amounts of unfathomable data, controlled by perhaps a few organizations, is not inevitable. So I was quite influenced by reading Philip Ruggawaite's article 4 years ago on the moral character of cryptographic work, which I would highly recommend. He talks about cryptography as an inherently political tool, with massive social structural consequences. But the exact same thing could be said about AI. So technology is not neutral. What kind of technology we develop can have a directional impact on society. And we need to work with social scientists and humanists to figure out what kind of society we really want to build. With this in mind, how should we change foundation models? I don't have an answer here, but I'd like to suggest a few possibilities. So existing foundation models are trained by a single organization with tons of compute. So there's been some work, I want to point out a project, Learning at Home, which challenges this. They're attempting to train models just based on volunteer computing, like Folding at Home for protein dynamic simulations, which for a moment was the world's largest supercomputer. They're trying to do it for training large models. And this really is a hard technical problem, but it would have huge accessibility implications on who could even train these models or what it means to train these models. But it also heightens other challenges, such as security and risk of misuse. So one can extend this decentralization to the decentralization of data as well, like federated learning. So why should my vacation photo end up in some training set that's used to power some vision system of a self-driving car or even classify chest x-rays? So instead of thinking about pooling all the data together to train one giant model, can we think of instead of a world where there's a set of private models, where each model is controlled by certain organizations, and this data that is used to train these models are only pooled together in accordance with strict protocols? Again, this is a very technically challenging problem with a lot of implications on privacy and security and power. So if we think about the whole ecosystem from data curation to training a model, to adapting it to downstream tasks, to deploying the model, I think we need to better characterize the properties of these data sets and models, like specification sheets for materials. So work on data sheets, model cards, and the big sciences data governance group are all really important works in this direction.
1 minute.
So now there's massive data sets. Are they really necessary? Some recent work has shown that you can get some of the gains from even synthetically generated data, or maybe even better architectures or careful initialization. This would really help mitigate some of our dependence on data for these hungry models. So these are just a few ideas. And I really hope that during the course of this workshop, we can come up with more ideas. I think of these foundation models as just a proof of concept that certain things are achievable. I think we need to explore much more radical steps if we're thinking about renovating these models. So I want to say that we are still in the very early innings. It's incredibly how fast that these models have developed. They're deceptively simple. It's just self-supervised learning at scale, giving rise to emergence. And this emergence is what makes the future so uncertain. But one thing is for certain, the homogenization quality of these models means that there's great pressure to build the entire AI's ecosystem on them. And the stakes are high. If we create good foundations, we can enjoy much more efficient, fair, and robust AI systems. But if we don't, we can end up in a very volatile state. So we need to work together as a community to achieve the former and not the latter. So thank you for listening, and now I'm happy to take any questions. So the first question is, Stanford has built a center, organized a workshop, and written a large report, Stanford internally. How does Stanford and CRFM intend to collaborate with other institutions? This is a great question. I think we're in the very beginning stages where the center is meant to just coalesce and get people at Stanford talking to each other. The idea, as I've alluded to in my talk, is certainly collaboration, engagement with a community. We're talking with the big science and Hugging Face projects. We need to also work with industry because ultimately they're the ones who are deploying these models, and we need to stay grounded to the facts. And I really hope that what we've done here is something that other universities can do as well. Just like every university has AI labs or NLP groups, which form local communities, I hope that local communities in other places will happen. And this is really about enabling interdisciplinary discourse. So the second question is on disciplinary diversity. How should academic institutions work with these models? And where specifically do you believe that interdisciplinary and multidisciplinary collaboration is most critical? So one of the things that I think is really important, which I've grown to appreciate more, is that how intertwined the ethical and social awareness needs to be integrated into the technological development. I think we're currently in a mode where technology runs first, and you build these models, and then you think about ethics as almost a kind of an afterthought. Now we have to critique these models and say what goes wrong, and by that point, I think it's too late. Some of the critical decisions have been made already in a structural way, right? And I think we need to kind of reset and think about the needs of social benefit, and how do we imagine not just like building the architectures, but the whole process around how these models are developed. You discussed several potential paths forward. What paths is CRFM pursuing and why? So I mentioned CRFM has two thrusts: building infrastructure and building community. And I think these work in tandem. The infrastructure is important because I think having concrete access to these models and being able to tweak them and talk about them will enable us to actually kind of make this type of progress. The community is also very important because it allows us to bring a wide range of voices into the conversation. And so together, I'm really hoping a world where we have these artifacts and which are open and transparent, and we can have interdisciplinary scholars who are well versed in actually the technical details, and technical scientists who are well versed in the kind of social concerns, and we can have a meaningful discussion about how to move the things forward. How will we work toward decentralized foundation models? I think decentralized foundation models has been something on my mind. And to be honest, I'm not really sure how to go about it. I think the Learning at Home project and other efforts in federated learning, I think these are good starts. But I think there's incredibly a lot of challenges, both technical and social here. And I think decentralization has to be an integral part of the story. It's just the only way that you can scale and have teams. Even within a big company, some amount of decentralization is necessary if multiple teams are meant to kind of engage. So I think thinking about this decentralization from the get-go is incredibly important, independent of decentralized efforts to train an actual model, right? So we're so used to thinking about a singular model, and everything is kind of model-centric, and there's good reason to be there. But there's this whole ecosystem about different organizations, data sets, different stakeholders, and mapping out that whole ecosystem, I think, needs to happen to make meaningful progress on this problem. And let's see, maybe I'll do one final question before moving on. What do we see beyond foundation models? Are there fundamentally different routes at arriving these models? What about approaches that don't involve foundation models at all? So this is a good question, which I hope we'll discuss actually more in the panel. But just quickly, I want to separate out existing foundation models, which are based on this large data set, deep learning networks based on transformers, from the general notion of building foundations for AI. So in many kind of paradigms in AI, there has been a kind of a desire for foundations which are general purpose and reusable. In society, we have infrastructure like electrical grids and roads. So idea of foundation, I think, is very natural. Whether these foundation models technically are the right approach, unclear. And whether we can adapt them to be best for society, we need to discuss that. So I think it's important to maybe separate the kind of aspirational goals of building foundations for AI and where we are currently.